So our topic will be about solutions to first-order differential equations, and it will focus on variable transformation. And we have two cases here. The first one, it involves equations with homogeneous coefficients, or the homogeneous differential equations. And for case number two, those equations containing coefficients linear in the two variables. Okay, but first let's focus on homogeneous differential equation. So um, let's get to know, or let's be clear here with what homogeneous functions are. Okay, so here I have examples of homogeneous functions. I have 5 examples here, but the first 3 examples, as you can see, these are polynomials. Just looking at the given function, I can say that these are homogeneous functions or homogeneous polynomials. So what is a homogeneous polynomial? So a homogeneous polynomial is a function in which um, the degree in each term are the same. So take a look at example number 1. So we have x squared minus 3x plus 4y squared. So the degree in the first term of this function is 2. And for the second term, we have, okay, so for x, we have 1, and for y, we have 1. So 1 plus 1, we have 2. So the second term has a degree 2. And for the last term, y squared, the degree for this particular term is 2. Then this is a homogeneous function since the degree in each term are all the same. And this is a degree 2 homogeneous function or homogeneous polynomial in that case. Polynomials can be easily determined whether or not it's a homogeneous function. Okay, for the second example, we have x cubed plus y cubed. As you can see, the first term is of degree 3 and the second term is of degree 3. Now, this is clearly a homogeneous polynomial since the degree in each term are the same, right? So we can only say that a function is homogeneous if the degree in each term are the same. Okay, so number 3, we have x raised to 4 times y plus 7y to the 5th. So again, this is a homogeneous polynomial or function since the degree in each term are the same. So first term, degree 5. Second term is degree 5 also. Therefore, since they are the same or of the same degree, then this is a homogeneous function or a homogeneous polynomial. Okay, now, so it's not always the case that you can determine the homogeneity of a function on the degree in each term. Well, for the case of polynomials, you can say that whether or not the function is homogeneous, but there are other functions that is not really obvious. If you look at the given function, it's not obvious that it's a homogeneous function. So it's not limited only. Homogeneous functions are not limited to polynomials. Okay, clear? Just like these last two examples here. Number 4, you have 2y cubed e raised to, multiplied to e raised to y over x minus x raised to 4 over x plus 3y. Okay, and we have number 5, x divided by the square root of x squared plus y squared. So these last two examples are homogeneous functions. So how? Paano nangyari? Like the first 3 examples, they are very obvious that the degree in each term are the same. That's why they are homogeneous functions. So again, it's not limited only to polynomials. So even though there are functions like exponential in it or radical functions, we can still say that a given function is a homogeneous function. Okay, yes, any question? Everyone?
Sir, paano po namin ma-determine kung homogeneous po yung 4 at saka 5?
Okay, so yun yung i-explain ko. Okay?
Okay po, sir.
Okay. Sige. If you want to talk, just unmute your microphone na nakamute kayo currently. Sige, para lang ma-avoid natin yung unnecessary noise. Okay, or unnecessary na mga sound. Anyway, can you hear me clearly?
Yes, sir.
Okay, that's
Yes,
great.
sir.
Now, let's go to the formal definition of homogeneity of a function. So this explains, diba, why examples 4 and 5 are homogeneous functions, even though they're not obviously, or but just looking at the given function, it's not so obvious na homogeneous function siya. But this is actually the definition or the formal definition of homogeneity of a function. So the function f of x and y is said to be homogeneous of degree k in the variables x and y if and only if the function of lambda x, okay, lambda is a Greek letter, lambda x, and lambda y is equal to lambda raised to k times the given function times the original function f of xy. Okay, so what can you say about this definition? So if you introduce lambda in the given function, okay, it's like replacing x by lambda x and replace y by lambda y, and you happen to, or you can be able to factor out lambda in the given function, or still you can see the original function there, and factoring out lambda in the given function, then that function is a homogeneous function of degree k. So this k here, this represents the degree of the given function, okay, of the homogeneous function. If you can't be able to factor out or to remove lambda in the given function, it means that that function is not homogeneous. Okay, so let's try to examine example number 4. Why this equation consider or this function I mean, why this function is considered a homogeneous function. Okay, so here determine whether or not the function is homogeneous, and if it is homogeneous, state the degree of the function. So let's just go over that example, number 4. It's 2y cubed times e raised to y over x minus x raised to 4 over x plus 3y. Now, what we will do here, since we let this as our function f of x and y, now by applying the definition, the formal definition of homogeneity of a function. So we replace x by lambda x and y by lambda y. So it means that if you can see variables here, x and y, you replace them by lambda. Okay, the product of the lambda and that variable. Okay, x for lambda x, y, okay, replaced by lambda y. So here, so take a look at this. As you can see, I just copied 2, and then I replaced y cubed by lambda times y raised to 3, or basically it's lambda cubed times y cubed. Now in this function, e raised to y over x, we have y replaced by lambda y and x by lambda x. So let me just write in here that term. Sinasabi ko na lambda. Okay. Ayan. Lambda. Okay, going back here. So lambda y over lambda x minus the second term. So you have x raised to 4. So you replace x by lambda x. So lambda x raised to 4 is lambda raised to 4 times x raised to 4. Now we divide it by, of course, this function here in the denominator. So you have x, replace that by lambda x. And here you have 3y. So replace y by lambda y. So now you have applied all the lambdas in the variables, or you have or we have replaced x to lambda x. We have replaced y by lambda y. Now, the next step is for us to be able to factor out or to remove lambda, if we can be able to factor out lambda. So let's just think that lambda is another variable being introduced in the function. Okay, it's a variable that you can introduce, that we have introduced in the function. Okay, on the first term, as you can see here, e raised to lambda y over lambda x. So what can you say about this expression here? We can be able to cancel lambda, right? So you cancel lambda in this corresponding or this particular function. Okay, so we can be able to remove lambda there. Now, here, since it's already in factored form, 2 lambda cubed times y cubed, our concern now here is the second term. Okay, so we have lambda raised to 4, x raised to 4. Okay, so in the denominator, you can see that in each term, there is 1 lambda, right? So you can factor out lambda in the denominator. Okay, so having factored out, or just, imagine, okay, or just try to uh, picture out this one. So factoring out lambda, so we have lambda raised to 4 divided by lambda. So what's the answer? Lambda cube. Now we have lambda cube in the first term and lambda cube in the second term, then we can be able to factor out lambda cube in the entire function. So here, as you can see, this is the result of simplifying or factoring out lambda in each term. So again, just a review. So we have canceled lambda in this exponential function. That's why we have e raised to y over x. In the second term, we have factored out lambda. That's why we have, after dividing lambda 4 by lambda, we get lambda cube. Now, lambda cube is common in each term. That's why we factor out lambda cube. So what happens after you factor lambda cube? So what remains is still the original function, right? Did you see this? So you can still see the original function. So being able to factor out lambda in this formal application of the lambda in the given function means that that function is a homogeneous function. Or by just looking at this given function here, you can see that degree 3 yung lambda mo, and then degree 3 yung lambda mo sa second term. So it just shows that the degree in each term is the same, okay? Okay, in reference to the lambda. So this exponent of the lambda represents the degree of that function, okay? So this is this function is homogeneous of degree 3 in x and y. Any question here? Question? Clear ba tayo dito? Okay, so clear naman. Now let's go to example number 2. Okay, so here we have x over the square root of x squared plus y squared. Of course, the given function of x and y is equal to x over the square root of x squared plus y squared. So we are after of knowing if the given function is homogeneous or not. Then we will apply what is being stated in the definition or the formal definition of homogeneity of a function. So we replace x by lambda x and y by lambda y. So on the right side of this equation, so x becomes lambda x, and the denominator we have x squared becomes lambda x raised to 2, or basically lambda squared times x squared. Same with the second term in your denominator, so you have lambda squared times y squared. So as you can see here, lambda squared is common in the denominator, so you can be able to factor out lambda squared in the denominator. Thus this given denominator is in factored form, so you can actually take the square root of these factors. So square root of lambda squared is lambda. And what remains in the function here is you have the square root of x squared plus y squared in your denominator. As you can see in the numerator, you still have lambda there. So lambda divided by lambda, again, just think lambda as another variable being introduced in the given function. So you can be able to cancel them. So lambda divided by lambda, so it's equal to 1, or basically what's the exponent of lambda if you were able to cancel it? Anyone? What's the exponent or the degree of the lambda if you were able to cancel it? Hello? Anybody there?
1.
Okay,
Zero.
we were able to cancel, right? So it's 0. That's right, because lambda raised to 0 is equal to 1, right? So any number raised to 0 is equal to 1. That's why we have this resulting uh, representation or illustration of being able to determine the homogeneity of a function. So we have here lambda raised to 0 or equal to 1 times the original function. So it means that, okay, so we were able to factor out lambda in the given functions. So this is a homogeneous function of degree 0. So again, for functions, so the degree of homogeneous functions are not only limited to positive whole numbers, just like determining the degree of an equation. But for homogeneous functions, the degree could be a negative, 0, a fraction. Okay, so those are the possibilities. Okay, clear? Again, for the degree of homogeneous functions, it's not limited to whole numbers. It could be a negative number or any integer, and then a fraction. It could be 1/2 degree, okay, referring to the given function. Okay, question? Now let me ask you this. Okay, what is or let me draw this equation. How about square root of x plus y? Okay, so can somebody tell me what is this equation? What is this function? Is it homogeneous or not? Yes, Marlon? Uh, is square root of x plus y a homogeneous function? If it's homogeneous, what is the degree of this function?
1/2.
Okay, 1/2, right? Because if you introduce lambda here and lambda in the second term, you can be able to factor out lambda, right? So x plus y. And you have the square root, right? So both factors are in the square root symbol. So you can be able to get the square root of lambda. So that's lambda raised to 1/2 times the square root of x plus y. Okay, so this degree here represents, of course, the degree of the homogeneous function. So tama, it's 1/2 degree. Okay, homogeneous function of degree 1/2 in x and y. Are we clear here? Okay, so let me give you an instance that a function is not homogeneous. So just like this one, polynomial. So x cubed plus x times y plus y cubed. Well, obviously, the degree in each term are not the same, but applying the homogeneity of the formal definition, uh, how do we do it? So by replacing x by lambda x and y by lambda y. So let me just get my pen again. Okay, here. So you apply lambda, so it becomes lambda cubed times x cubed. On the second term, you have lambda times x and then multiply that to lambda times y plus, here you have y cubed, so lambda cube times y cube. Now, so the second term, you have lambda times lambda, so we have lambda squared times x y. Okay, so as you can see, there are lambdas in each term, but the common lambda that you can see in each term is lambda squared. So factoring out, let me just copy this first. So okay. Okay, so since common yung lambda squared, since not all terms, diba, have the same degree. So factoring out lambda squared, we have this resulting function. So you have lambda x cubed plus the product of x and y plus lambda y cubed. So as you can see, you were not able to, or we were not able to factor out lambda. There is still a lambda or lambda in the given function, okay, here, right? So it means that this function is not homogeneous, okay? This is not homogeneous because you were not able to eliminate lambda in the given function. So in polynomials, it's very obvious. You can easily say whether or not the function is homogeneous. Okay, other examples, let me just erase everything here. Okay, say for instance, let me just take a look at the book here. Okay, just like this one, e raised to x. Okay, my question is e raised to x a homogeneous function or not? Everyone? Anybody? Is e raised to x homogeneous or not? Hello? Okay, so e raised to x is not homogeneous. Okay, because if you apply the homogeneity, the formal definition, so if you replace x by lambda x, then you can't be able to factor out lambda, right? That's why it's not homogeneous. Okay, but for this example, ln of x minus ln of y, is ln of x minus ln of y a homogeneous function?
Yes, sir.
Yes. Why? Because you can actually
Pwede
rewrite
pong
this on.
factor out yung lambda.
Are you sure? Okay, so if you put lambda here and lambda here, so how can you be able to factor out lambda there? Okay, so by following the property of logarithmic functions, you know that lambda of a given function minus the ln of a function minus ln of another function is equal to ln of this function divided by, okay, another function in the second term with a minus sign. Okay, so as you can see here, you can cancel out lambda, right? So you were able to eliminate lambda. And what is the degree of that function? It's 0. Since there's no lambda there, automatically the degree of the function is 0. So that's it. So this ln of x over y is a homogeneous function of degree 0. Okay. Any other questions before we go to homogeneous equations? Okay. Ano yung case na negative naman yung degree ng function? So for example, if it's 1 over square root of x minus y. Okay? Ako na yung nagtatanong sa inyo. Ako na yung nagpa-present ng mga possible questions. So this given function is actually homogeneous and of degree negative 1/2. Why degree negative 1/2? Okay, take a look at this. So 1 over square root of, so introduce lambda here. So x by lambda, x becomes lambda x, and y becomes lambda y, right? So factoring out lambda, so you have lambda raised to 1/2, okay, times the square root of x minus y. So since lambda is in the denominator, so if you bring this up, the exponent will become raised to negative 1/2. So times the original function, which is 1 over square root of, okay, 1 over square root of x minus y. So this given function is a homogeneous function of degree negative 1/2. Are we clear, everyone? Okay. Silence means yes. We are clear. Now we can proceed to the next slide. So here. Now we'll talk about homogeneous functions and how we can be able to solve equations with homogeneous coefficients, or how to solve homogeneous equations or differential equations. Okay, so we have a theorem in DE that states, that says, if m, a function of x and y, and n, a function of x and y, are both homogeneous functions and of the same degree, the function m over n is homogeneous of degree 0. So, tama naman, di ba? If both functions, yung m and n, are of the same degree and homogeneous, if you are to put them in ratio, so yung lambda na ma-introduce natin will be canceled out. So, knowing that if there's, if there's no lambda in the given ratio, it means that the degree is 0. Okay? So, again, suppose that we have this equation, m, this form of DE, the given coefficient, a homogeneous function, m of x and y dx plus n of x and y dy equal to 0. And these coefficients, m and n, are homogeneous functions and of the same degree. This equation is actually a homogeneous differential equation. So again, you have to take note that this coefficient m and n are homogeneous functions and of the same degree. Na kapag kinuha mo yung ratio nila, degree 0 siya. Okay? Pagka magkaiba kasi ng degree, pwedeng homogeneous function yung coefficient ni dx, pero iba yung degree niya compared to the coefficient of dy, which is n is another homogeneous function. Pag magkaiba sila ng degree, it will not be considered a homogeneous equation. Clear? Guys? Na kapag kinuha mo yung ratio, magiging degree 0. Okay? Basta lahat ng terms na makikita mo sa equation are of the same degree. Okay? Or constant yung mismong degree nila. Is it clear? Thumbs up. Okay, so if this equation is homogeneous equation, now how can we solve, or how do we solve equations, okay, involving, coefficients with coefficients that are homogeneous? Okay, so we do variable transformation. So we introduce a variable, or we replace one of the variables there. So it's like substitution. So it's either we use y equal to vx, and of course, replacing y by vx, you have to replace also its differential. You have to replace dy by Of course, differentiating Vx, that's v dx plus x times dv. Or you can also use x equals v times y. Again, so you can either use one of these transformation depending on the convenience in the equation. But most of the time we use y equal to v times x. Now I will show you two examples that I have utilized y equal to vx. In the other example, I have utilized x is equal to vy. Okay, but in cases like there are two terms in the coefficients of dx and dy, then for uniformity, we use y equal to vx. If in case lang ha na pareho yung number of terms ng coefficients ni dy tsaka ni dx, we use y equal to vx para same tayo. No? Well, kahit alin dyan, it will lead us to the same kapag ka nagkuha na tayo ng particular solution. Yeah. There are many solutions kasi in DE. Okay, so clear na ba tayo dito? So I think clear na. Now let's solve example number 1. We are to solve x squared minus xy plus y squared times dx minus x times y dy equal to 0. Now take a look at the given equation. So the coefficient of dx and dy are homogeneous functions. Okay, but the question is, yung mga coefficients ba ni dx at ni dy are of the same degree na homogeneous function? So tignan natin. X squared, so degree 2, xy degree 2, y squared degree 2, and then xy degree 2. So since the entire equation or the coefficients there, mga functions natin, are of the same degree, then this equation is a homogeneous equation. Okay? Tandaan ha, this is a homogeneous function. If it's not homogeneous function, then you cannot be able to utilize the transformation that I have said earlier. There may be another way for you to solve that DE. Okay. So degree 2 nga. Diba? Pag kinuha natin yung ratio, so degree 2 ito, and then degree 2 din ito. So 2 over 2, maka-cancel natin. Or lambda squared over lambda squared is equal to lambda raised to 0. That's why degree 0 yung ratio niya. But kapag coefficient lang pinag-uusapan dito, pareho sila ng degree of the same degree. And that is another way of finding whether or not the given equation is homogeneous equation. So in here, we will put y equal to vx, and then we replace dy by its differential, na v dx times x dv. So why did I use y equal to vx? As you can see, yung coefficient ni dy is just one term, okay, compared to the coefficient of dx, which is a three-term coefficient, diba? 1, 2, 3. Because I'll be replacing, of course, the differential of y by these two terms. Then it's more convenient to utilize y equal to v times x. Clear? So just imagine if you are to replace, or if you are to put x equal to v times y, then you are to replace dx. So magiging ano siya? A polynomial multiplied to a two-term na differential. So it will be tedious, okay? Matrabaho siya compared to, replacing y and dy here. So distribute mo na lang yung one of the variables in each term dun sa differential. Okay, I hope it's clear to you. Now we are to replace y by vx and dy by v dx plus x dv. So giving us an equation containing variables x and v. So take note. So after substituting these conditions here, or what we have initially put here, the resulting equation should not contain variable y anymore. Okay, we have replaced y by vx, and it's differential by v dx plus x dv. So just like this, x squared, just copy, and then copy x, replace y by v times x, and y squared by, of course, v times x raised to 2. We just copy dx and then minus x, replace y by v times x, and dy by its the differential v dx plus x dv equal to 0. Now the next step is for us to be able to, okay, simplify muna natin, and then the second term here is we have vx squared. Remove the grouping symbol here. This becomes v squared x squared, and then here we multiply x times vx, so we have v times x squared. So as you can see, yan, naka-factored form naman siya. We have x squared, x squared, x squared. Means we can be able to factor out x squared here on the first term. And we have x squared here on the second term. So we can actually eliminate x squared by dividing both sides by x squared. Thus, we have this resulting equation. So again, anong ginawa natin dito? We divide or we eliminate x squared since common yung x squared sa bawat term natin. So clear na ba tayo dito? That's why we have 1 minus v plus v squared times dx minus, okay, so na-remove na yung x squared. So we have v times the quantity v dx plus x dv. So usually, after natin gawin itong pagpalit ng mismong variable na y to vx and x dv, it will lead us to a separable dE. Again, please take note, kapag ginagawa natin itong homogeneous equation, we are leading to, a separable differential equation. Okay, ganun lagi yung case na kapag nagawa na natin yung substitution or transformation, we can be able to separate the variables. Okay, so let me just distribute first. Ito. So 1 minus v, so pinagpares ko na sila, and then times dx, v squared times dx. If we multiply, distribute natin yung negative v sa bawat term dito, we have minus v squared times dx, and we have minus v times x dv. As you can see, you can be able to cancel v squared dx here, right? So tanggal na tong term na to. And anong matitira? We have 1 minus v dx minus vx dv. So ito na, this is a separable differential equation. Okay, we did transformation and leading to a separable dE. Now what happens? We separate the variables. Okay, so let me show you what I have solved earlier. So here, copying ko muna 1 minus v dx minus vx dv. So what I did is I interchanged their positions. So magiging, gawin mo siyang positive. So factoring out negative here. So we have v minus 1. If we distribute negative, the same pa rin naman yung kalalabasan niya. Since negative na in each term, so I can multiply both sides of the equation by negative 1 para matanggal na yung negative sign. And separation ng variables na, di ba? Yung v, punta kay dv. Yung x, punta kay dx. Right? Now, paano kung gagawin yon? Kailangan pure function of x yung nasa first term ko. So, kailangan kong matanggal, or I should eliminate v minus 1. So, dividing both sides by v minus 1. And the second term here, I have vx dv. So, ang kailangan ko lang dito is ang variable v. So, I need to remove or eliminate x. So, by dividing both sides by x, then I have the resulting equation dx over x plus v times dv over v minus 1 equal to 0. So a pure function of x, pure function of v. Then we can integrate each term. So integral of dx over x is ln of x. And this one, so I have isolated this first kasi ang ginawa ko is dinivide ko muna v by v minus 1. So dividing v by v minus 1. So I have here, ang result is 1. Ayan, v minus 1. And then v minus v, 0. And then minus times minus, you have positive 1 here. So may remainder ka. So you have 1 being the quotient plus the remainder, di ba? 1 plus v minus 1. So ibig sabihin, the result of v or this ratio or fraction na to, v over v minus 1 is equal to 1 plus 1 over v minus 1. So, kasi walang direct na formula para ma-solve ko to. Diba? Yung integral nito. So, ang ginawa ko is dinivide ko muna siya. Okay? Now, I have here integral of dv, and that is v. That's integral of dv over v minus 1. So, that's ln kapag, yan. Tingnan natin sa next page. So, we have ln of x plus integral of dv, which is v. Integral of dv over v minus 1 is ln of v minus 1. So yung c natin, para ma-simplify the entire equation, so ginawa ko is I put c being ln of c. And pinagsama ko yung parehong ln na to, naging product na, di ba yung argument? So ln of the product x times v minus 1. And then we take the anti-ln or yung basis exponential para ma-remove natin yung ln na function. So e raised to ln of x times v minus 1 plus v equals e raised to ln of c. That's why we have the product x times v minus 1 times e raised to v kasi nga, di ba, exponential, di ba, na property. So e raised to v equals c. Now, this is not yet the final answer because we have replaced one of the variables by, we have introduced v in the given equation. So recall that y is equal to v times x. Now, if we are to bring back the original variables, v is equal to what? Y over x. So replace v. Don't forget to do this. Kasi pag nandito ka lang banda, mali yung sagot mo. Okay? You have to bring back the original variables. So replace v by y over x. So we plug in here. So we have x times y over x minus 1 times e raised to y over x equal to c. Now we simplify here. We know that y over x minus 1 is equal to y minus x over x. So we can cancel x here. That's why our final answer is y minus x times e raised to y over x equal to c. Now, any question? Any clarification? Meron bang hindi naintindihan at kailangan kong explain ulit? Okay, that's great. We can proceed to the next example. Okay, so here we have a differential equation xy dx plus x squared plus y squared times dy equal to 0. Okay, so again, take a look at the given equation, yung coefficients na dx at ni dy. Are these functions, are these coefficients homogeneous? Okay, so x times y, very simple lang example ko, the x times y, homogeneous function, degree 2. Ayan, homogeneous functions. Tandaan ha, kapag x squared plus 1 na ito, hindi na yan homogeneous function because kailangan, para masabi mo na homogeneous function siya, kailangan may presence ng mga variables doon, tapos pareho yung degree nila. E kapag 1 yan, you cannot be able to determine the degree of that constant. I mean, constant, di ba? Hindi mo pwedeng sabihin niya may degree siya. Kasi constant nga. So x squared plus 1, tandaan ha, is not a homogeneous function. But here, x squared plus y squared. So degree 2, then the first term natin, degree 2 din siya. So the same degree in each term. Pag kinuha mo yung ratio ng coefficients ni dx at ni dy, degree 2 over degree 2 is maka-cancel natin, di ba? So 0 ang power nila. So this is a homogeneous differential equation. Now, what is the appropriate transformation here? So kanina ginamit natin y, we replace y by v times x. In here, we are to put x equal to v times y. Okay, bakit ko napili ito? Kasi it's more convenient in this given equation since yung dx has one coefficient, one term na coefficient pala. I mean, not one coefficient. Pero naman sila naman may coefficient eh. But here, the number of terms in dx na coefficient is only one. And for the dy naman, dalawa yung number of terms. That's why it's more convenient to replace x here because you are to also replace or to transform its differential. So dx equal to v dy plus y dv. Nagets niyo ba yung point ko dito na kung anong pipiliin ko, x is equal to vy or y is equal to vx? Pero nabanggit ko rin kanina, I have mentioned earlier that if there are two terms in the coefficient of each of the differentials, a number of terms, pwedeng y na lang gamitin mo. Y, replace it by v times x. Okay? Let's go. So replace natin yung x by v times y. Again, if you differentiate this, this is dx equal to v dy plus y dv. Now, so copy lang natin yung y, x becomes vy, and then dx is equal to what? V dy plus y dv. So we have here. And on the second term, we have x squared replaced by v squared y squared. And you copy y squared and times dy. So as you can see, kailangan, okay, sorry pala dito. Wala tong negative nagkamali lang yan. Okay, let me just, okay, so here, what can you say about the resulting equation? It involves variables y and v. So no more variable x in the given equation. So kailangan clear tayo dyan na you were able to remove or to replace one of the variables. Now the next step is to distribute or to take a look at if there are like terms so you can combine them. So gawin lang natin, we combine each term. So what I did is distribute ko muna yung, okay, anong ginawa natin? Going back here. So, oh, take a look at this given equation. So y times vy is equal to vy squared, right? So let me just get a pen so you can see. So vy squared, right? And then you copy this given differential. And then here you have also, you can factor out y squared here, right? So this becomes v squared plus 1. Okay, so having seen y squared in each term, so if you divide the entire equation by y squared, yan, tanggal na yung y squared dito, tanggal na yung y squared dyan. Ayan, so matitira na lang is v times this given differential times v squared plus 1. Yun yung makikita mo sa next na page natin. So, tada! This is the resulting equation after you have divided the entire equation by y squared. So now here we are going to distribute v. So v squared times dy, v times y. So you have this given term. And then distribute natin itong dy in each term. So v squared dy plus dy. And then what we will do here is, okay, my dy, dy, dy. So combining, like terms. So v squared dy plus v squared dy is equal to 2v squared dy. Now here, just copy this one. And we were able to factor out dy, di ba? Kasi 2v squared dy plus dy, factoring out dy, you have this term. Are we clear? Now, we can separate the variables. Ito yung sinasabi ko na after you have done, manipulation and you have done transformation, it will lead us to separable differential equations. So in this part na ng ating equation, we can separate the variables. So here we only need the variable v for dv and we need variable y for dy. So eliminate y here, dividing both sides by y. That's why we have here y in the second term. For the second term naman, divide the entire equation by 2v squared plus 1. So ganun lang yun, or nag-cross multiply lang tayo. So you have 2v squared plus 1, yung denominator ng first term natin. A pure function of the variable v, a pure function of y. Clear? So we can integrate each term. So integral of this first term, integral of dy over y. Okay, now we have the resulting integral ln to, di ba? If you are to check 2v squared plus 1. So the numerator should be, para magamit natin yung logarithmic na or ln na formula, kailangan ito yung differential yung nasa numerator. So we need 4v dv. So what I did is I introduced a neutralizing factor na 1/4. So put 4 here and then divide outside by 4. So you have 1/4 ln of 2v squared plus 1. And for the second term, we have ln of y equals, and you need to simplify since pareho naman yung ln to. And then tanggalin natin yung fraction dyan. So I have introduced 1/4 here, ln of c, and multiplying both sides of the equation by 4. That's why we were able to eliminate 4 here. So nandito na yung 4 natin. For ln of y equals ln of c. Now we can combine them, right? So ang mangyayari sa 4 is gawin mo siyang exponent ng argument nitong logarithmic function sa term na to. So magiging ln of y raised to 4. Okay, so this is combining um, these two terms, magiging ln of 2v squared plus 1 times y raised to 4. And then to eliminate the ln function, so you get the anti-ln of both sides of the equation, so e raised to this given side of the equation, and then equals e raised to ln of c. That's why we're able to eliminate ln. Then the resulting equation is 2v squared plus 1 times y raised to 4 equal to c. Ayan. So, pero hindi pa to yung final answer. We need to bring back the original variable na x, knowing that x is equal to v times y. So v is equal to x over y. Now we replace v by this ratio, x over y. So yung v squared natin dito, magiging x squared over y squared. So the rest, as is lang yan. And then we are to manipulate or arrange this equation. So 2x squared, copy lang natin, and then this becomes y squared over y squared, or having the same denominator. And then, so all over y squared here. So y raised to 4 divided by y squared is equal to y squared. Kaya our final answer is 2x squared plus y squared, and quantity times y squared. Okay, equal to c. Any question here? None? Nakuha niyo na kung paano gawin? Okay, I think we're good. Now, I will give another example na pareho yung number of terms. And I'll be utilizing y equal to v times x, but that will be sa next meeting natin. So we'll have a 30-minute lecture next meeting if you are available on Thursday. So please attend. Kung hindi naman, it's okay. The session will be recorded and I will introduce this another topic. So you have actually two problem sets. So yung una is homogeneous for this particular topic, homogeneous equations, and the second one is it involves coefficients linear in the two variables. So ito yung case number 2 natin. So it involves coefficients na linear in the two variables. So yung a sub 1, b sub 1, c sub 1, these are actually constants. Yun yung ating next topic. Okay, so that's all for today. And thank you all for attending this class. I hope you learned a lot or you learned something today and you were able to um, understand or how to solve equations involving or having coefficients that are homogeneous.
Sir, may